next one, actually. I'll just jump right into it. Validation requirements. One of the benefits of ETH 2.0 is that you can run a validator on fairly humble hardware, I'd call it. $1,000 laptop, you can run a Ethereum 2.0 node right now, versus Cosmos, and especially some of the more high activity chains, high throughput chains. You're never going to get that. You're going to have to buy some actual real good computing hardware, or do some sort of cloud compute non-bare metal thing. So I can dive more into it later, but I'll let Jack step in here with any thoughts.
Yeah, this is like back to the Bitcoin fundamentalism of you need to be able to run it on a Raspberry Pi. So as a side note, you can run a Tendermint validator on a Raspberry Pi. And Jacob from Notional has been doing a bunch of work on that. The memory and CPU requirements are not insane. As long as the CPU is decently fast, it doesn't need to have a ton of threads. It's the single thread performance of the individual CPU that kind of makes the difference. And then beyond that, it's kind of disk and networking, which do not depend on the underlying computer itself. So the requirements to run a Cosmos node aren't as high as people think they are. B, we have not really optimized storage at all. And there's actually a lot of like wasted space in the storage side of things. There's a lot of database optimization work that we've kind of left undone. And I think that it will be very easy to go back and kind of do that database optimization work. And a lot of it is ongoing right now. So yeah, I don't know. Does anyone else have thoughts on this?
I think with ETH2 also coming back to the fact that you have to run multiple validator nodes, the complexity of running like a single node might be less, but the complexity of running like 100,000 nodes is quite high, and making sure that every single one of them is performing at the threshold that it needs to be adds a lot of complexity, which means that as an aggregate, you like the operations of it becomes harder as the bigger you become. And so I think there's some complexity that comes from that aspect that Tendermint doesn't have, in my opinion. But
I kind of want to comment because, like both Jin and I worked at Intel, and then like I worked before joining Saga. I was in Silicon for the last 10, 12 years. And one of the things that really attracted me to the Cosmos ecosystem is, one, it seems to be gaining a lot of people and founders who I think are very technology driven, who are about the technology. So I think that's fascinating. The other thing is it kind of reminds me of a parallel situation that happened in IoT 10 years ago during the maker movement, where people would get a single board computer and it was very hard to connect it to the internet. And then a lot of work went into optimizing what was called, the developer experience, user experience, so that you can get your IoT device, set it up, connect it, make it live in like 10 minutes. That took a long time. That was quite hard. And what you just said about the Raspberry Pi and the Lite client, I think there's the potential for some, validator experience. And a set of tools were created to solve this problem on the IoT side, like Baylina and Mender, and they address the problem. So I think that I could see a world where these validators are this experience of setting up these streamlined validators gets easier and easier through some of these automation tools that were already created in the prior era.
Yeah, as far as the validator automation tools, this has been a passion of mine. Like I got into blockchain after working in the traditional cloud world, and we built out amazing automation tooling for the database we worked on. And that was how we ended up getting user adoption. And I brought a lot of those lessons that I had learned doing that work into Cosmos. And I think that this is kind of one of the fundamental differentiators we have. And one of the big areas I've been working with the Saga team on is helping to ensure that this huge explosion in complexity that's going to come from requiring validators to run many chains is manageable, understandable, and scalable for those validators. And it's tools like Horcrux that enable you to take the key signing part of the architecture of a validator and shard it into something that's highly available that can then serve signatures for many, many different chains. These are the types of like core technology work that then get wrapped with things like Helm charts and different deployment procedures and standard deployments that come together to make an operator experience nice and easy. And adding monitoring at every layer of the stack, like as you can see, there's a large number of tasks here that are required of operators. And the more that we as engineers can help ease that burden, we're going to have more and more operators. So we're going to make it easier and easier for operators. So I think that that's one of the things that I'm most excited about Sega about, is that that's what you guys are really thinking about at the core.
Right. I mean, orchestrating a bunch of ETH nodes is conceptually at least pretty similar to orchestrating a bunch of Saga chainlets, right? So you're just in the first scenario, you're validating the same chain, where in the second scenario, you're validating technically different chains, but like the actual work that goes into it is probably pretty similar, where you need to spin it up, make sure monitoring is there, and it's going to be a different binary that runs, and you're going to have to make sure that they're performing properly. So I think